The James Webb Space Telescope, JWST, has revealed indications that suggest human-like activities occurring far beyond our planet, bringing us closer to resolving the age-old inquiry of whether we are truly alone in the cosmos. The quest for extraterrestrial life has been a recurring theme throughout human history, inspiring countless works of literature and theories about the subject. Our fascination with our place in the universe and the possibility that we are solitary beings appears to be ingrained in us, driving a persistent desire to find companionship. Possibly even from entities not of this world, we are approaching the answers to the questions we hold dear. But are these answers truly what we are looking for, or is something deeper at play? In 2021, the JWST posed an intriguing hypothetical question about the future capabilities of our technology. Could our telescopes detect artificial lighting on a planet like Proxima B? This exoplanet, the closest to Earth, resides within the habitable zone of our nearest neighboring star, Proxima Centauri, approximately 4.25 light-years away. It was believed that Proxima B might be tidally locked, much like our moon, meaning the planet would always face its star on one side. This idea led to the possibility that a technologically advanced civilization on Proxima B could have the means to transfer heat and electricity from the planet's day side to its night side using photovoltaic cells, which generates electricity from sunlight. A subsequent paper, co-authored by Manasvi Lingam and others, suggested that if Proxima B's day side were covered with solar panels, future telescopes might be able to detect this activity. Now, in 2024, with the advancements in sensitivity and capability that the JWST offers, it is possible that the telescope could help us further explore the potential for artificial light or conditions that are habitable on exoplanets like Proxima B. This breakthrough could propel humanity toward another significant leap in its evolution. Before examining the implications of such a discovery, it's important to understand how such a feat became achievable. The James Webb Space Telescope mission continues to unravel the mysteries of Proxima Centauri B, a prime subject of research throughout history. Humankind has continually sought answers to the most fundamental questions about the universe, our existence, and our destiny. These profound, though difficult questions have driven our curiosity ever since we became human. With the rapid advancements in modern technology, the question arises, are we any closer to finding answers to these agiled mysteries? A philosopher might argue that we are still in the infancy of our understanding of the universe and of ourselves, while astronomers eagerly share the most recent cosmic discoveries, using the tools and technology available to them. Although such advancements might often go unnoticed by the general public, they represent monumental milestones in human progress as we continue to advance in our exploration. Now, with the world quite literally at our fingertips, we are poised to explore the cosmos in ways never before imagined. One of the key tools leading this exploration is the JWST, built upon the legacy of human space exploration. This instrument is designed to answer fundamental questions about our place in the cosmos. It has already begun to provide insight into the potential for life beyond our solar system, as shown by the most recent discovery of possible artificial light on a planet located light-years away. Proxima B, also known as Proxima Centauri B, is a terrestrial world orbiting an M-type star. These planets are typically more massive than Earth, but lighter than ice giants like Neptune or Uranus, forming a unique class in the universe. While much remains to be uncovered about Proxima B, this breakthrough marks a significant step forward in our ongoing quest to better understand our place in the cosmos. The first potential evidence of exoplanets dates back to 1970. Though it garnered little attention or recognition from the scientific community at that time, it was not until 1992 that the first exoplanet was confirmed, astonishing scientists and sparking further research. Since then, many other exoplanets have been confirmed, One of the most notable discoveries occurred in 2003. As of April 1st, 2024, a total of 5,653 exoplanets have been confirmed across 4,161 planetary systems, with 196 of those systems having more than one planet. These groundbreaking discoveries are predominantly associated with M-type stars, also known as red dwarfs. Red dwarfs, small stars found on the main Hertzsprung-Russell sequence diagram, are much more common in the Milky Way than other types of stars. However, due to their dim light output, observing them is not as simple as observing brighter stars. Red dwarfs are classified based on their temperature and size, typically referred to as M dwarfs, with surface temperatures around 3,900 Kelvin. These give them unique characteristics. Proxima B's mass is estimated to be about 1.07 times that of Earth. Remarkably, completes an orbit around its star in only 11.2 Earth days, compared to our 365.25-day orbit, suggesting the small size and mass of its parent star, Proxima Centauri. The star itself is notably faint across the electromagnetic spectrum, emitting only 0.16% of the sun's luminosity in visible light and just 0.056% in the visible spectrum. More than 85% of the energy it emits is in the form of infrared radiation. Proxima B orbits at a distance of approximately 0.04856 astronomical units from its star. The discovery of Proxima B was announced in 2016, raising the question, why has this particular exoplanet sparked so much interest? One reason is that Proxima B is the closest known exoplanet to our Sun, located just 4.2 light-years away. While this is vast by human standards, it's relatively short on a cosmic scale. Proxima B is part of the Alpha Centauri system. Despite its host star's low luminosity, it remains a major point of interest for astronomers. The Proxima Centauri system is one of the best-known stars visible in the night sky, ranking just behind Alpha Centauri and Sirius in brightness. Perhaps the most intriguing aspect of Proxima B is its potential habitability. Positioned within the habitable zone of its star, it presents possibilities that have driven astronomers to embark on missions to investigate the star system's full potential. This is where the JWST plays a crucial role. The telescope's scientific goals include searching for light from the first stars and galaxies formed after the Big Bang, studying the formation and evolution of galaxies, understanding the formation of stars and planets, and investigating planetary systems and the origins of life. As the JWST continues its exploration of exoplanets like Proxima B, we move ever closer to achieving these ambitious objectives, the search for extraterrestrial life. And specifically, extraterrestrial intelligence is a primary focus in space exploration. The quest for signals from intelligent civilizations stems from humanity's innate curiosity, a desire to understand everything that moves and everything that does not. This endeavor has frequently been likened to a cosmic treasure hunt, only instead of gold, we seek electromagnetic transmissions, potential murmurs from civilizations far beyond our present comprehension. As we progress in our pursuit of extraterrestrial intelligence, the implications of discovering artificial illumination or other indicators of life on celestial bodies like Proxima B are immense. Such revelations would not only improve our understanding of the universe, but also redefine humanity's role within it. The notion that we are not alone could revolutionize how we perceive ourselves, reshaping philosophies, societal structures, and even our future on Earth. Should we detect evidence of intelligent beings on another world, it would be a pivotal milestone in human history. Much like the historic moment when humans first walked on the moon, it would signify the dawn of a new era in space exploration, one in which Earth is no longer the singular harbor of consciousness in the cosmos. What would such a discovery mean for the future of space exploration? A foundational mission of the James Webb Space Telescope is to close the gap between our current scientific understanding and the immense unknown that lies beyond. With its cutting-edge instruments, the JWST was designed to observe deeper into space and further back in time than any other telescope before it. This extraordinary capability enables researchers to examine remote stars, galaxies, and planets with unprecedented precision, shedding light on the processes that shape the early universe. As we accumulate more data, it becomes increasingly plausible that discovering microbial life or even intelligent life from other planets is not merely theoretical, but likely. Proxima B exemplifies the myriad of exoplanets situated within their star's habitable zones. It's planets that could potentially sustain life. The technological strides represented by the JWST and similar tools are unveiling avenues of exploration that were previously inconceivable. These tools allow scientists to analyze exoplanets in extraordinary detail, identifying even the most subtle clues of artificial origin. The hunt for life beyond Earth has never been more thrilling. Each new insight brings us closer, step by step, to resolving one of the most essential questions in human history. Are we alone? Beyond the search for life, the JWST is enriching our understanding of planetary systems and how they develop. Astronomers benefit from studying planets such as Proxima B to learn how solar systems behave, how planets form, and how they adapt to their unique environments. These insights not only inform our knowledge of distant worlds, but also illuminate possible futures. And Martian. The goal of expeditions is to find evidence of earlier or current microorganisms, possibly revealing clues about the evolution of life on other planets. Similarly, future missions to the remote frozen moons of Jupiter and Saturn may expose environments where life might persist in forms unfamiliar to us. The JWST stands as a monument to human innovation and inquisitiveness, a device that enables us to explore the universe more deeply than ever. Each discovery refines our perception of the cosmos, guiding us through the unknown. Artificial light, a new era of detection. The potential to observe synthetic lighting on distant exoplanets is just one illustration of how the JWST is redefining our scientific landscape. As we extend our reach into space, it's likely we'll encounter findings that question conventional wisdom, beliefs, and fuel new lines of inquiry. Even as our focus expands outward, we must contemplate how these findings will affect life on Earth. The realization that we may not be the only intelligent species could profoundly influence policy, global culture, and ethics. It may compel humanity to reconsider what it means to exist, both as individuals and as a species.